We all identify with the clothes we wear, and we have the freedom to choose the type of print, color, size that suits our tastes. However, isn't it contradictory that we buy clothes that do not match our values? Nowadays, the excessive consumption of fast fashion clothing has caused the textile industry to be responsible for 10% of humanity's carbon emissions. According to the World Economic Forum, the fashion industry is responsible for 20% of all industrial water pollution worldwide. In other words, every garment purchase contributes greatly to water pollution. It is as if for every new garment we buy, we were to pour a bottle of toxic chemicals into a fish tank full of living creatures. Could anyone dare? Therefore, some companies are developing new strategies to bulk these trends in order to implement more sustainable methods for cotton production and cut back on textile production. Also, in March 2020, the United Nations launched the project Alliance for Sustainable Fashion with the purpose of reducing the harmful effects of this industry with the support of agencies. That is why today more than ever we must be aware of the life cycle of clothing, paying special attention from having a sustainable production to having zero waste and pollution in the final part. We have decided that if there is no environmental friendly clothing on the market, we have to create it. Nano-Textiles creates textile fibers from cellulose, producing clothing whose raw material is 100% natural and therefore biodegradable.
When we are talking about nanoscale, it is essential to comprehend what a nanometer is. A nanometer is 1 times to the power of minus 9 meters or a billionth of a meter. For example, a human hair, which is around 6 to 10 centimeters, is equivalent to 60,000 to 100,000 nanometers. To have a better perspective of the scale we are referring to, if we consider the diameter of the Earth as a meter, then the diameter of a marble would be a nanometer.
Why is it a good idea? Well, firstly, cellulose is the most abundant and renewable natural resource on Earth and can be obtained from different sources like wood, cotton, and vegetables biomass. It has a range of features that can have a wide advantage over other materials due to its nanoscales. Some of its characteristics are that it has biocompatibility, it is biodegradable, it has high mechanical strength, making it optimal to mold. It is a light material, meaning its weight is similar to cotton, impermeability to a certain point, and it has non-toxic properties. Our raw material for the production of nanocellulose is organic waste generated by local restaurants, supermarket, food industries, and farmers. Most of the waste from these companies are various types of fruits and vegetables, among other waste rich in cellulose content. We take advantage of organic waste that would otherwise be wasted by reusing it to create a valuable product. After the extraction, we will treat the cellulose with the lyocell process. The method is the first discovered dissolution process for cellulosic fibers. It was patented by McCorsley in 1981. It is made by multiple steps. First step is dissolution. It consists in dissolving pulp from any rich cellulose fiber like wood in amino oxide solution. After this, here comes the filtration. The solution is filtered by precipitation in a precipitation bath and forms filaments or staple fibers. Some of the restant water, pulp, and organic solvents are reused. Third step is the spinning step. The fiber is inserted into a spinneret and regenerated in a coagulation bath using a rotating drum to obtain it. Number 4 is the washing process. The washing process is a process in which the organic solvent, water, and pulp is recovered and reused. Finishing. The finishing part is the post-treatment processes that the fibers are subjected to, like drying and bleaching. Some advantages involve the opportunity market that revolves around nanocellulose. It is estimated that it will grow from 760 million euros up to 1.35 billion euros in a lapse of 10 years. It has a high price, but it involves high rewards. Use of water will be reduced and waste will be recycled, hence the cost-benefit win will be high. Additionally, it does not use as many toxic chemicals that could liberate emissions harmful to the environment, making our process sustainable and ecological. Our innovation in the lyocell process is mainly the use of a new waste-based raw material. Additionally, there are some improvements made in the recollection and reusage of compounds needed during the process, like water, organic solvent, and even the pulp that wasn't used.
Nowadays, considering green chemistry principles is so relevant to design better products and the processes to manufacturing them. According to this, the manufacturing process we are proposing fulfills the principles 1, 5, and 7. These principles involve waste reduction, avoiding the usage of hazard chemicals, and the usage of renewable feedstocks respectively. What will we do? We will obtain nanocellulose by the lyocell process and make daily usage products. We will focus on dresses, handbags, different kind of clothing, and headwear. In a few words, we will start a revolution in the modern textile industry. We are attempting to contribute to the Sustainable Development Goals 6, 9, 12, and 13, which refers to clean water and sanitization, industry innovation, responsible consumption of our resources, boosting the tendency of take actions to combat climate change. In the short term, we will get in contact with some companies that produce organic waste in Querétaro, Mexico, to obtain our raw material and produce nanocellulose. The raw material we expect to work with will be the waste from brewing industries, such as beer bagasse, the stubble from wine companies, and the agricultural residue from corn and bean crops. We expect to increase the raw material to other agricultural residues in other parts of Mexico, such as sugarcane bagasse.
The next step is to produce our first prototype with our designs to evaluate how to improve our processes. Once our final textile is obtained, it will be marketed. Will have a long useful life and can be reincorporated into the nanocellulose cycle, either by composting or by reusing the textile. Our cultural impact lies in changing the mindset of an entire generation, creating awareness while offering an innovative product that people need and love is the ideal way to generate a change in favor of the planet. In addition, with new technologies come the creation of new job opportunities and the development of never-seen-before technologies.
However, we have recognized that we still have some challenges to face. For instance, first challenge, finding the financial investment to develop the lyocell process. What is our solution? We have defined our cost structure and will seek financing and sponsors mainly for the purchase of specialized equipment.
The second challenge is to find our best raw material supplier. The solution is to find companies that do not have alliances with other sectors, such as livestock, to sell their organic waste. We have to present in a clear and innovative way our project to the possible interested parties, convince them by offering a better price than the market and explaining the benefits that they can obtain.
The third challenge is to take care of sustainability at every step of the production process. We propose to implement a nanocellulose-based dye which is expected to reduce water consumption approximately 6 times compared to the chemical dyes and after 10 washing cycles maintain almost 93% of the original color. In summary, it is essential to state that nanocellulose and the lyocell process are revolutionary elements to make the garment and the textile manufacturing process in general more sustainable. Our mission is to encourage society to have a more sustainable lifestyle, starting by changing their clothing practices and offering a quality textile coming from organic waste produced in a sustainable way with a circular economy model and congruent with people's values. The future looks one way. It will be dressed in nanocellulose.